Okay, we're on problem number 16. Let's see, they drew us something here. Let's see, point from point A to point B. I have a line. And then I have another from B to C. And then I have another from here to here. Okay, so what are they telling us? They tell us that this is a 90-degree angle. Oh, whoops. Not what I wanted to do. Edit, undo. I'm using the wrong tool. So they tell us this is a 90-degree angle. This is a 90-degree angle. This is A. This is B. This is C. This is D. And they say the figure above shows the route of Diane's trip from her house to her job. Diane travels 16 miles from A to B, so this is 16. 15 miles from B to C, so this is 15. And 4 miles from C to D, so this is 4. If she were to travel from A to D directly, how much shorter in miles would the trip be? So what would be the direct route? I'm assuming they're kind of talking, if she could fly, what would be her direct route? So that would be this route. Oh, I thought I was using the line tool. Edit, undo. Well, I'll do it in a better color anyway. So use the line tool. So this is the direct route right here. This is what we want to figure out, the distance of this. So how can we figure out the distance of this? And the trick here is to just realize that this is going to be the hypotenuse of a right triangle. And it might seem confusing. Your initial impulse might have been to say this is x and this is 15 minus x and all of this fancy stuff. Or what you could do is you can say, well, this side here we know what this is, this length. Whoops. Let me redraw it a little bit better. That length, what is that length? Well, this length is going to be the same as this length, right? If we assume this is a 90-degree angle, it's going to be 15. And then what's this length right here? What's this length right here? Well, it's going to be the same as this length up here, right? I just kind of extended a rectangle. So this length right here is 4. So what is this entire length? It's going to be 16 plus 4, so it's 20. So now what we're trying to figure out, her straight line distance, is nothing but the hypotenuse of a rectangle, of a right triangle, where we know the other two sides. So we can say if this is her straight line distance, x, we could say x squared is equal to 20 squared plus 15 squared. Or x squared is equal to, let's see, this is 400 plus 225 is equal to 625. And the square root of 625 is 25. So x is equal to 25. So her straight line distance is 25. And how far was she traveling before? Let's see, she was going 16 plus 15 plus 15 plus 4. So that's 20. She was going 35. What is that, miles? Right, miles. She was going 35 miles, and if she goes straight, she goes 25 miles. So she would save 10 miles if she went straight, if she was able to fly. So that's choice C. Next problem. Problem number 17. Problem 17. One circle has a radius of 1/2, and another circle has a radius of 1. What is the ratio of the area of the larger circle to the area of the smaller circle? So let's see. So the area of circle 1, area 1 is going to be equal to what? It has a radius of 1/2, right? So it's pi r squared is the radius. So it's pi 1/2 squared. And what's the area of circle 2? The area of circle 2 has radius, so area of circle 2, it's pi times its radius. And its radius is 1. So it's 1 squared. So the ratio of the area of the larger circle to the smaller circle, which is going to be the larger circle? This one is, because it has a larger radius, right? It has a radius of 1. So the ratio of the larger circle to the smaller circle, and that might be where you messed up if you flip the two. The ratio of the larger circle to the smaller circle is equal to pi times 1, right? Well, that's just pi, over pi times 1/2 squared. 1/2 squared. The pi's cancel out, so we have it equals 1 over 1/4. Or what we could do is we could multiply the numerator and the denominator by 4, which equals 4 over 1. So the ratio is 4 to 1, and that's choice D. Problem 18. Image, clear image. Problem 18. If the sum of the consecutive integers from -22 to x inclusive is 72, what is the value of x? So this is a number, we've actually done a problem very, very similar to this. So it shows you that people in the SAT, they think of a lot of creative problems, but every now and then they have to repeat. So they're saying the sum of the consecutive integers from -22 to x is 72. So let's think about this. Let's draw the sum. So it's, it's -22 plus -21 plus -20, right? Plus, and it keeps going until it gets to 0 plus 0, and then I'm gonna go this way, and I'm doing that for a reason. And then you can say plus 1 plus 2 plus, and you keep going, and then you'd have plus 20 plus 21 plus 22 plus 23 plus 24, all the way until we get to x, right? But what you need to realize is all the way from -22 to 22, the sum is 0. And why is that? Well, look at the way I drew it. So -22, we're taking the sum of everything, right? So -22 is going to cancel out with +22. You add those together, you get 0. -21 is going to cancel out with +21. -20 is going to cancel out with +20, and so forth and so on. So everything, so the sum from -22 plus bam, 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 all the way to +22, that equals 0, right? So we only get into the positive sum once we get to 23, right? So 23 plus 24 plus so something is x, right? And we have to get to 72. 72. And here we can just eyeball it. 23 plus 24 plus 25. What's that? Well, their average is 24. 24 times 3 is 72. Or we could just add it up. Let's see. 23 plus 24 is 47. 47 plus 25. It equals 72. So the last number that we use in this whole range is 25. So this is x. That is x. And all we did is we said, think about it. Take the sum from -22 all the way to +25. Everything up to -22, from -22 to +22, all of those cancel out with each other. So the sum is just going to be 23 plus 24 plus 25. And that equals 72. So then x is 25. Next problem. I'm running out of time, so I better do it in the next video. See you soon.